Folks, hello and welcome to Business 660. It's a pleasure to have you along with us here for the next 8 weeks, and I certainly hope that this course meets your expectations. Each week, what I'm going to do to help you get started with the homework is I'm going to go through just kind of an overview and maybe a little setup to help you get started on maybe 2 or 3 problems each week. And hopefully this is helpful to you as you get going. Obviously, we can have as much discussion about these as you want in the course. There's a link in the course on the left-hand column that says class questions, and you're absolutely welcome to use that anytime you like to ask questions about course content. And it's always helpful that you do it there. That way everybody has access to the same information. And again, it's just very helpful to everybody if we ask the questions in that forum. So what I thought I would do for this week, I've got 3 problems that I want to kind of tee up for you here, 4, 5, 4, 11, and 4, 15. I'm going to start with 4, 11. 4, 5 is a little bit longer, and I like to try to keep these to about 15 minutes so I don't bore you with my voice and everything I've got to say about this stuff. I love talking about this material. I think it's great material for everybody, but certainly don't want to make you sick of me the first week. But anyhow, problem 411, and this is from your section on decision analysis. And so this problem talks about building luxury high-rise condominiums. It looks like we've got a small complex option, a medium complex option, and a large complex option. And then we're given some probabilities, the possibility of having strong demand for each of these, or one of these, I should say, one of these complexes, strong demand, weak demand. And it's given in the statement of the problem that the strong demand has a probability of 0.83 and the probability of weak demand is about 0.17. And so the first thing that you're asked to do here, I'm going to just solve problem or help you set up and solve problem A. Problem B is the same problem. You just got to go back and adjust some of the computations here, but that that computation follows exactly the same as what I'm going to show you here in A. So the first thing we're going to recognize here as you go through the reading, this table that gives this information here, information about the small, medium, and large complex. I don't even know here. Let's see if we're given. I should have mentioned this up front using. Yeah, I'm assuming that this is probably millions of dollars based on some of these other values that they're talking about. So we'll assume that the values here in the table, for example, the small complex, let's see, for strong demand will have a profit of $8 million and so on and so forth. So what we're going to do here first, and let me go back again, this is what we're going to call the payoff table. This is giving us all the information we need about the complexes and the demand. And you'll notice I've replicated that over here. And what I also did is I put the probability of strong demand, 0.83 here, probability of weak demand here. And that is going to allow us, if you remember back in your course in statistics, there's something called an expected value. So when you have a discrete random variable and you want to compute the long run expected outcome, you can take each outcome and multiply it by its associated probability, and that will give you the expected value. And so the first thing I have done here is I found the expected value of each one of these complexes given the payoff for strong and weak demand and the respective probabilities. So let me just show you here how I did this, just to remind you. So the expected value of the small complex is going to be the outcome times the probability. So 8 times 0.83. I've actually used formulas. I'll post this spreadsheet so you have access to this and you can see all my formulas. So I've just multiplied 8 times 0.83 and I've added to that 7 times 0.17. So the expected value, if we did this a number of times under these conditions, the expected return on a small complex would be about $7.83 million. And I've gone through and done the same computation, 15 times 0.83 and 3 times 0.17, and so on and so forth. So based on this, even with a loss of about $8 million, if the demand happens to be weak for the large complex, the expected value is about $15.25 million. So it looks like right now the best option under these conditions would be to build the large complex. And then the question that we're going to ask here in part A says, consider the medium complex decision. Oh, sorry about that. Consider the medium complex decision. How much could the payoff under strong demand increase and still keep alternative D3 as the optimal solution? So if we go back and we look at that, what we're saying here is what will the payoff for the medium complex under strong demand, which is currently $15 million, we're going to assume that that's actually a variable price at this point, or a variable payoff at this period, and then we'll figure out how large that payoff can become in terms of still allowing us to keep the large complex option as our primary option at 15.24 million. So the inequality that I've set up here, this will take you back to your algebra days here a little bit. Just a reminder, my variable X is the payoff for medium complex under strong demand. So assuming that the probability for strong demand remains at 0.83, I have 0.83 times X plus $3 million times 0.17%. Again, that's still from the table, 0.3 times 17. And we want that to be less than the expected value or the expected payoff for the large complex down here that I show in the green. So one more time here, 0.83 times X, X again being the payoff for the medium complex under strong demand, 3 million times 0.17 less than or equal to 15.24 million. And it looks like here I just multiplied 3 times 0.17 gives me 0.51. And then remember, just the old algebra step, treat this as an equality, subtract 0.51 from both sides. So I have 0.83x is less than $14, or I should say 14, almost $14.75 million. If I divide both sides by 0.83, the price can increase to about just something just less of 17.75 million on the medium complex, and we would still keep the large complex decision in play as long as this value of X or this value here stays under 17.75 million. And then same thing for the for part B. I think you're just answering same thing, though the small complex is the decision that you're going to make, and again keeping the D3 or the large complex as the optimal solution. So just some quick adjustments to this inequality and you will have it. Before I go any further, let me mention that when you get into the homework, you'll have a list of questions here from Cengage. Anything that says that is algorithmic, it will mean that all of us will have different numbers that we're dealing with. We'll all be answering the exact same scenario, but the information that you're given will differ from student to student. So when you go in to do your homework and you pull up problem 411, it's very likely that you are not going to see these same values in the payoff table, and it's likely that the probabilities of strong demand and weak demand will be different. However, the approach will be exactly the same, so no issues on that. Let's see. So I got a little long-winded on this one. I will be not so long-winded on the next one. This one is about 9 minutes, but in order to get those other two in the same video, let me just let me pause here and terminate this video, and then I will produce one more video for you that goes through problem 415 and let's see, 4, 4, 5. So hope that's helpful to get you started, and I'll see you on the next video.